Hi guys, it's Paco. I'm about to give a presentation on the article from the National Geographic about renewable energy. The article explores the various sustainable energy sources that are essential for reducing humanity's reliance on fossil fuels. As climate change accelerates, transitioning to renewable energy has become a global priority. The article highlights different types of renewable energy, their benefits, challenges, and their role in shaping a cleaner future. The article categorized renewable energies into several key forms. Solar energy harnessed from the sunlight using photovoltaic cells or solar thermal systems. Solar power is abundant and scalable. It's particularly useful in remote areas but depends on the weather condition and requires significant space. Wind energy generated through wind turbines. Wind energy is highly efficient in windy regions. However, it faces challenges like noise pollution and impact on wildlife. For hydropower, one of the oldest renewable energy sources, hydropower uses flowing water to generate electricity. While reliable, large dams can disrupt ecosystems and displace communities. For geothermal energy, it's derived from the Earth's internal heat. Geothermal energy is stable and efficient, but is geographically limited to volcanic or tectonically active regions. And for biomass energy, it's produced from organic materials like wood and agricultural waste. Biomass is versatile but can also contribute to deforestation and air pollution if not managed sustainably. The article emphasizes the environmental and economic benefits of renewables. It reduces carbon emission. Unlike fossil fuels, renewable energy produces little to no greenhouse gases. And it creates energy independence. Countries can reduce reliance on imported fuels by utilizing local renewable resources. And it also creates jobs. The renewable energy sector is a growing source of employment in engineering, manufacturing, and maintenance. Despite their advantages, renewable energy sources also face obstacles. It faces intermittency. Solar and wind energy depends on weather conditions, require energy storage solutions like batteries, and high initial costs. Infrastructure setups, for example, solar panels, wind farms, it demands significant investment, and also land use conflict. The large-scale projects might compete with the agriculture or conservation efforts. The article also concludes by stressing the importance of technological advancement and policy support to accelerate the adoption of renewables. Innovations in energy storage, smart grids, and government incentives are crucial for sustainable energy transition. And here's my comment on the article. The article highlights key renewable energy sources like solar, wind, and hydropower, which align with the lecture discussion on energy transformation and sustainability. From a physics standpoint, these energy sources are fundamentally rooted in the conversion of natural phenomena into usable energy, governed by the principles such as electromagnetic induction, photovoltaic effects, and energy conservation. For solar energy, the article mentions solar energy is a prominent new renewable source which connect directly to the lecture's explanation of photovoltaic cells. Silicon-based solar cells operate by absorbing photons from the sunlight, breaking chemical bonds to free electrons and generate electric current. The efficiency of these cells is limited by the material properties and energy losses, but the advancement in nanotechnology could improve this. The article could emphasize that solar energy intermittency and energy storage challenges are crucial limitation for physics and engineering perspective. And for wind energy, wind turbines convert kinetic energy from airflow to electricity via electromagnetic induction. The lecturer explained how Faraday's law underpins the process. Rotating coils in magnetic field induce current. The article could note that wind energy scalability depends on the geographic wind patterns and the turbine design, which affect energy output and mechanical efficiency. And for hydropower, the Three Gorges Dam example illustrates how gravitational potential energy of water is converted into kinetic energy and then electricity through the turbines. The article could expand on how it relies on energy conservation principles with efficiency tied to water head height and turbine technology. And for energy storage and challenges, the lecturer stressed that renewable energy systems require efficient storage solutions like batteries due to their viable nature. The article briefly touches on this but could delve deeper into the physics of energy storage such as chemical reaction in batteries and the inefficiency in current technologies. Energy and nuclear energy as a complement, while not renewable, nuclear fission offers a high energy density alternative with minimal greenhouse emissions. The article could contrasts new renewable energies with nuclear energy role in a balanced energy portfolio, noticing its challenge like waste disposal, safety, and advantages like efficiency and low carbon footprint. To conclude, the article effectively introduces renewable energies but would benefit from integrating physics-based explanation into energy conversion, efficiency limit, and technological constraints. Highlighting these principles would provide readers a deeper understanding of why renewables are both promising and challenging, aligning with the lecture themes of energy transformation and sustainability. Thank you.